Okay, so for our second practice problem, we have the question above on the screen. And so to start off, we want to place our points where the charge is. And so we have a charge here, and we'll name that Q, charge here, and we'll name it P. And so at charge Q, we know that the charge is a negative 2.0 microcoulomb charge, and it has a mass of 0.3 kilograms. For the charge P, we know that has a positive 6 microcoulomb charge, and the mass is 0.4 kilograms. And so to start off this question, we want to know the principles used. And so the principles used is electric potential, which I'm going to shorten to V, due to a point charge. And so that equation is given by V is equal to 1 over 4 pi epsilon naught times Q over R. And so the assumptions that you need to make for this is that as R increases to infinity, electric potential, or V, is equal to 0. So first off, we want to start by drawing a triangle with Q here, P here, and we're trying to find R. And so we know, based off of this graph on the top, that this is 9 and this is 9. And you find this by adding the two values together. And so we find that R is equal to square root of 9 squared plus 9 squared, and that R is equal to 12.73 meters. Now that we know that, we can plug it into the equation V is equal to 1 over 4 pi epsilon naught Q times Q over R. And so we know that Q is equal to negative 2.0 times 10 to the negative 6 coulombs, because it is in SI units. And so because we're trying to find the electric potential at P, we're using the surrounding charge. So that's why we use negative 2.0 microcoulombs. So therefore, we get the equation to be 1 over 4 pi epsilon naught times 2.0 times 10 to the negative 6 coulombs all over 12.73 meters. And then you get that that is equal to negative 1,412.7 volts. And that is our answer.
If you answered this problem incorrectly and did not come to this answer, it could have been due to the fact that you used the charge at this location where we're trying to find electric potential. This was the misunderstanding that was noted earlier, so we would only use the surrounding charges to find electric potential. So in this case, only at point Q. Another misunderstanding that could have caused error would be incorporating mass into this equation. If you notice that the electric potential equation here does not include mass, therefore, if it was somehow included, there would cause a great amount of error.